Hello, my name is Roland Reyer. I'm a technical specialist at Autodesk Media Entertainment in Europe. Here's version 1 of my compound pack Procedural Polygon Generation for Bifrost. The goal of these compounds is to create a construction history in Bifrost that uses different simple initial objects, simple blocks of a few polygons, to create complex buildings that automatically adjust to the scale. The concept for this kind of modeling was presented by my colleague Maxime Jeanmougin at the GDC 2022 as a Platinum Games employee, and he referred to earlier work by Akira Saito. Okay, so let's jump right in and work with this object that I've prepared here. It's basically a cube that I have used, or where I've used the polycube node to set the width, the depth and the height. And then I created a bevel on this object. The advantage of this method is that now I can change the width and the depth, for example, without the bevels to change. So the bevels will remain their 45 degrees here and will not be deformed by scaling the cube, for example. Of course, I can later scale the cube as well. So we take this object and middle mouse drag and drop it into the Bifrost graph that I've already created. I can delete the input node here and I will connect it right away to the output, like so. And I can hide the cube that's in the scene. So what we see right now is the output back from Bifrost into the scene. So we can select now the wire here and create a PPG multicut node right away to see how the multi-cutting works. And you see nothing happens here because every node and also the multi-cut node has a section for selecting tags or selecting faces here. And by default, you know, there's a face tag name set, and this name does not exist here. So at the moment, the Maya component tags are not used anyway, so there is no face tag here that this multicut node could select, so it's not doing anything. We could of course just enter an asterisk as a wildcard and then it would cut everything. So now you see, okay, all of the faces, maybe except the triangles here and the six-sided face here down here is not cut, but everything else is cut somehow. But it's really difficult to tell what it does. So before we go on with the whole thing, we should include a PPG diagnostics node, which creates colors here. The colors are very bright and pink and so, but it also provides us with these face tags here directly on the faces. So this is the diagnostic node that shows us these face tags, and the face tags are absolutely necessary to see because after a while you get completely lost what the face tags would be after a certain operation. Okay, right now it's cutting everything and that's not very helpful. First thing I could do here would be to change the random seed for the use for the colors on the surface. I'm going to change this to 1, like, okay, I get at least different colors for the cuts. But in general, it is not very helpful that it cuts everything. So let's turn this thing off again and also turn off these diagnostic arrows that we see here and first select something. And that is the problem with the procedural modeling. The selection has to be procedural as well. So you cannot touch it. You have to do it somehow. You have to explain it somehow procedurally. And there are a few nodes that you can use for that. One in particular that I'm using a lot would be called Select Faces by Normal. And it does exactly what the name says. So here in these nodes, these selection nodes, the tag expression is automatically set to a wildcard. So it uses everything, every face on the surface and filters certain faces out. And select faces by normal means I'm giving a vector here and I want to select all faces that have a normal that is similar to this one here. So the upper Y coordinate. So nothing is selected but just the upper side of this whole thing, and the face tag that it creates here is selected faces, but I could also say it's the roof, for example. Okay, so we have done the roof already. Oh, let's have a look at all of these settings here. This vector here, I can of course bend it around. there's a goal and a tolerance setting. So the tolerance setting allows me to say, okay, I not just want this face on top here, but also some of the faces that have a similar direction, like 45 degrees in the same direction as my up vector here. That would be, done with the tolerance section. So let's take that back here. Another setting is this goal setting here. One means I want this vector here exactly. So I only want those faces that point in this direction, plus minus tolerance, of course. If I set this to a smaller value, I can select faces that are 45 degrees from my vector. And if I make it even smaller, like 0, I can select faces that are 90 degrees from the actual vector that I adjusted here. So I'm having the side faces at the moment. And when I set it even smaller, like -1, then I would select the bottom of the whole thing, because that would be the exact opposite of what I have here. So I'll set it back to just the roof here, and I'll create another select faces by normal, to pick the shoulder of this whole roof here. And again, we can do it, just with these settings here. So like so, and we call this here roof sides. And you see, by simply attaching a few of these nodes, a few of these selection nodes, so I make some more space to have more selection nodes here, I can pick everything. I can pick all of the faces in my scenery. So I'll simply make another select faces by normal here, and now I'll pick 90 degrees to the side. Actually, I can set this to 0 already. That would be the body of my object, or of my building, when I want to create a building here. So that's the body. And there's one face remaining, that's this one here. It is still gray, which means it doesn't have a face tag, but that's not true. It does have a face tag, but it's the default face tag. And the default face tag is normally filtered out here by the PPG diagnostic with this little expression, exclamation mark, minus, minus. The default face tag is minus, minus, or dash, dash. And by saying exclamation mark, I mean I don't want that one. So I can pick or create a new face tag here. There's a node called NFT, new face tag. And this new face tag, I can tell, hey, I want all the defaults, dash, dash. And I say I want this to be the bottom of my selection. So now we have all these face tags. I make them a little bit small, a little bit larger, so that we can see that in here. Scale them a little bit up so we can see now what the face tags are. We have the roof sides, we have the roof, we have the body. Yeah, maybe I want the bevels here. Okay, I want the bevels also to be separate. So let me make some more space here, and I'll include a new select faces by normal. And now I will look from the side, from the X direction, and not from the Y direction, like so, 0. So I'm looking from the side, and yeah, currently I have this one here. I'm looking from the X direction, but I want 45 degrees. So the cosine of 45 degrees is 0.707. So I should have the selected sides here. I also have a little bit of the roof. I can prevent that by saying I don't want to apply this rule to all faces. I just want to apply this rule to the body faces, nothing else. So I've ruled the roof out. So I have these two already, and the other two I get with this flag here, front and back sides. This will, apply the same rule to the back side of the object, so that I have the front and the back at the same time. Okay. That was cool. So we call these ones here bevels. Okay. Yeah, we have a little problem with the colors. They are all greenish here somehow. So let's go to the PPG diagnostic and change the random seed here, maybe back to 0. Oh yeah, back to 0 is not so bad. That gives me enough colors to tell the pieces apart. So we have the roof, we have the roof sides, body, bevels, and the bottom all separated. And now we can start using the multicut, and I can say, for the moment, I just want to cut the body. And now when I turn it on, you see, now that works. I have only the body cut. And now we can talk about the multicut. Keep in mind, so whenever you create these PPG nodes, you always have to set a tag expression somehow to either a wildcard or specific names, in the best case when you already have specific names, to tell exactly what you want to work on, because it needs to be all procedural. You cannot point at stuff and select it and then act like in Maya. So now let's go on and have a look at the PPG multicut. I'll turn back on the diagnostic display, which are these red arrows here. These red arrows are selected edges. So besides selecting the faces that you want to act on, you also need to select an edge, because that is important for the subdivision. The red arrow here shows currently which edge will be subdivided. So which of the 4 edges will be subdivided here. And PPG multicut will only act on four-sided faces. So it will not work on triangles or n-sided polygons or non-quads. Okay, so with this edge selection here, we have a way to define, hey, I want from the center of that face looking down, I want that edge that's downwards from here. That's what we do with this direction vector here. You can also select the longest edge or the shortest edge, or starting from a certain point index. So in this example, point index would work. The point index is always here in the lower left corner of a polygon, and they are numbered counterclockwise, of course. So if I don't want this edge down here to be subdivided, I can, for example, say I want the next edge from here. So counterclockwise, that would be this one here. And then I get my horizontal cuts. So this way I could cut my building into horizontal floors and then say, okay, one of these strips here will be a strip of windows, for example. We have so far, the edge selection, we have settings here for the outer size and the inner size. You see that outer, inner, the two alternate, and the outer side is called outer because that's surrounding the whole thing. It starts with outer and then comes inner, and then at the end there's always also an outer. You can set this with this menu here. You can have them on both sides. You can have half the width of the outer. That's like this setting here. You can say, I only want it on the start side. I only want it on the end side, using this direction here of the red arrow, or on no side, which, is kind of weird because now it turns around the outer and inner thing. But there's another thing that sets these two apart, the flexibility. We see that the inner part is currently flexible, which means when I take my cube here and scale it vertically, you see that the inner part is a little bit flexible. It works a little bit, and after a while it re-subdivides itself. Or maybe easier to see when I change the outer size a little bit. You see that the outer is changing, but the inner is flexible. So the inner can be squeezed for a moment, can be squeezed until it subdivides itself again and subdivides itself again into a new floor. So let's keep it like that. The new tags that appear here inherit the names of their parents. So the parent would be body in this case, and then an underscore and this new name that we have down here. And I can say, I don't want to inherit anything. I say, the outer tag would be the floor itself, and the inner tag would be the windows or windows strip, or however you may call it, for later use, in the next step. And the next step, I would say, we simply do another PPG multicut. And now I say, instead of, an asterisk or a wildcard, I say win strip. That's the one that we want to subdivide now. And you see that it gets subdivided horizontally in the horizontal direction. I make the face tags a little bit smaller so that we can better see. and we go a little bit closer. Okay. So now we could say, hey, we can keep working with this one here. We can extrude this stuff and work with that. I can also say, hey, I don't want these complex names, so forget the inheriting the face names. I simply say this is my window here, and the other one is my wall or something like that. Okay. So yeah, we didn't use the bevels yet. Can we include the bevels simply? Yeah, we can include these bevels in the whole process of cutting horizontally. I could say, hey, I have the body here, but I also include the bevels, like so. So now this is also cut. The problem starts, you know, when I subdivide it further like before. So what I did here was to say, hey, I don't care about the parent name, but if I include the parent name, then I can make a different handling for the bevels winstrip and for the body winstrip. So we could here say I'm subdividing the body winstrip with specific settings. Body winstrip. So here we have our subdivisions, and then I come back with another PPG multicut, for example, and handle the bevel winstrip in a different way with different settings, for example. Now let's have a look at these windows here and use another node. I simply select a wire before I create the node, PPG extrude in this case, and it will automatically include that new node in the wire, which makes the whole thing much faster. So, and I say I want to extrude the window in this case, because I know, you know, what the name tag is, and I don't want to extrude it to a certain distance. I simply want to extrude it a little bit in to create some sort of a window frame here. And again, I don't need any or to inherit any names. I can simply say this one is the frame of the window and this one is the window itself. And in the next step, I could now, you know, start and extrude the window in. We do something special here. So extruding the window in is a little bit unsatisfying. What I want to do now is take some of these windows, and we still have diagnostic display on here. So let me turn this all off. So we want to take some of these windows here and place some other objects in there. And that's called instancing. So there is a node called PPG instance. And this PPG instance simply takes some objects. So we say we want to replace the windows here. And it deletes the windows already, okay, and shows us a little coordinate system in place where the window is, and also has a selection for the selected edge, or a red arrow for the selected edge. We have all of that already, and then we have some instances here, simply some polygon letters that I created. I simply plug that into my instance geometries here. And now I have random letters placed where the windows are. And with the placement of the letters in the coordinate system, in the global coordinate system, I can move them a little bit in and out. So I could say, yeah, let's, you know, move that in the Z direction a little bit back here. So they really sit in the window. It's a bit boring because it uses all of these windows here. That's what we said. It uses all of these windows and you know, places their instances in there. Let me turn that off again, and we have a second look. And I also turn off the diagnostic display. What I can do here is to say I want to select random faces based not on all of the face tags, but just the windows. And here you see, okay, then it creates random face selection. And I could tell my PPG instance here, just take the random faces, like so. And when I turn it back on, we have an instance only in a few random faces. And that way you can place a balcony, for example. So these objects here are rotated and scaled so that they fit exactly inside these polygons that I'm replacing. So no matter how small the polygon is, I could even use the frames here around the windows and do instancing there, and it would scale these letters, these polygon objects, so that it fits inside this small polygon object. So that's what you have to keep in mind when you do instancing. It will force the scaling so that it works. And now I could go and use extrude, for example, and work on the remaining windows here, because the original windows or the random faces that I have here are already replaced. Okay, so in the next step, we're gonna take care for the roof and make a handrail around the roof, just to show you what you would do here. Okay, so you see that I'm starting to get a longer construction history. We had some space over here, so let's move this to the side. I can also make, my graph editor a little bit bigger from time to time, just to move these around. I'm keep pushing the PPG diagnostic onto the right side, because I need more space over here for new nodes to include into this wire. And what I want to do next is to work on my roof here and to make a small rail or small rim around this face, and then place some handrails on it with a multi-instancer node. So first what we're going to do is to extrude this thing. It's called the roof. And of course, I don't want to extrude it upwards, so this one goes to 0. I just want to make a small offset to have some sort of a rim around here. No need to make new face tags. So this is going to be the rim around my roof. Okay, and then in the next step, I will create PPG multi-instancer node, which should work on the rim here. So the face tag would be rim. And then you see it places a lot of little coordinate systems on that roof. So what we have here is a face selection or a selection, of course. So I can, select the longest edge, for example, that would work, but it works like it is currently. So I'm quite fine with the selection here, and also with the placement of this little coordinate system. So what's with an instance? I could create something, I could model, of course, something here, but for the moment, what would be sufficient was to just create a polygon cube, polygon mesh cube here, and feed it in here. So that's my instance geometry. And you see that it places a cube on every little coordinate system. That's the multi-instance. So it keeps repeating the same instance, or a number of instances, random instances if you like, along this polygon, and it places them in the middle of the polygon. So these are of course way too big. So we have a height here that we can use, and we can use the length and the width to make the whole thing smaller. So like, the support for a little handrail should work. If I place it in the polygon cube, I simply take the polygon cube and move it up a little bit. That's already big enough, so we don't need to overdo the height here. Like so, a little bit up, like so. Let's say this is my handrail, so I'm placing it roughly so that it works here. There are random settings here to randomize rotation, translation, and scaling of the whole thing. And there are distances. So we have a distance here of 1 unit. When I make this smaller, you see that more of these supports appear, and when I make it bigger, the distance increases. That's the real world unit distance between the single instances that we have here. And of course, I can also say I want a fixed number of instances on every polygon. Then this would work, of course, as well. So let's turn off the diagnostic display here for these supports. So now how do I get the handrail on top of the whole thing? That is again a simple PPG instance node. So let's create that one here. And we use the rim here. And it would delete the rim polygons, but I can prevent that. I can keep it from deleting the source face, and I also want a polygon in there. I could use the same cube, of course. Let me create a new one here. So that is my new mesh cube, and I plug it in as an instance. So the basic problem here is that, by default, it uses the down vector and then the next edge to place an instance upright into a window. So a window on the side, in a wall of a building, that is the normal use of this whole thing. And what we have here now is that we, want to select the long edge of these rim faces here, and we can do that by simply unchecking the next edge. So now you see already, this works much better. And of course we now have a size problem. We can translate the whole thing. Also the Y direction is not the thing that we want. I think it's the Z-axis here to move it up. And then it doesn't make sense to scale the cube itself, because instancing would always scale it up again to fit into that rim polygon here. So we have to do some sort of an additional scaling here, an additional relative scaling here. So I'm scaling in X and Z relative, and you see they overlap at the end. I have to make some space at the ends, like so. With the Y scaling, I can scale them so that it fits, and here's our handrail for the roof. And now, again, turn off the diagnostic display. I could, for example, already turn off the labels here to see how my work goes. And in the next step, we're going to work on the sides of the roof here and include some windows into that one. Good, so far not so bad. So let's turn the labels back on. We have the roof sides here. And what I want to do here is to cut these roof sides into strips and then include smaller windows here on the side. But these smaller windows are not just straight extrudes, they are wedges. So let's go and try that. So I'm gonna do a PPG multi-cut, and the face tag will be roof sides. Okay, well, that works already, not so bad. What should I change here? The outer size, maybe make that a little bit smaller. Actually, the inner size needs to be a little bit smaller because I want to have smaller windows here, like so, should work. And then I make another PPG multi-cut. And before I play around with that one, I should change the names here. So one is going to be, the inner is going to be my roof window. So R-Win should be the name. And here I'll insert that name R-Win in my top and change the axis. So the next edge to cut in a different direction. And then I make the outer size smaller because the inner is flexible anyway. And here's my inner window. So again, turn off the inherit source tags, and then the inner would be my roof window again. And with this roof window, so let's turn off the diagnostic display. We don't need that one anymore. So now I can make a PPG wedge node to get these roof windows here out of my roof. Win would be the tag. So here are my wedges. And the wedges, have a lot of tags here. Inherit is on. We don't need all of these subdivisions here. So actually basically only one. And it's still too big. A roof window wouldn't look like that. It's too far up. I can play around with the angle here and, move it back and forth a little bit, but it's too far up. You see that the PPG wedge also has a diagnostic display for the selected edge here. That is the rotation edge. But we need to scale these faces smaller. And again, the wedge front would be my, or let me call W-Win. Let me call it W-Win now and turn off the diagnostic display. And now we need to scale this W-Win a little bit down. And we can do that, in fact, with PPG transform. PPG transform is exactly for that purpose. We want to scale something. And we say, okay, we want to use the W-Win face tag. And here you see some coordinate systems and again, a selected edge. You can rotate stuff around certain edges, but the selected edge is mainly there to be able to say, what's the U and the V coordinate? Okay, and this little coordinate system shows you where in U and V the pivot would sit. So when I say, for example, I want to scale the whole thing, so the red arrow here is the x-axis. So I want to scale that face in the x direction. You see that it scales around the center of the whole thing, but I don't want it to scale around the center. Let me scale back here. I have this pivot shift X and Z here, and I can, move that pivot around. I can scale around this edge here, or I can scale around this point here. And then when I use the x-axis to scale, now it works. Now it does exactly what I want. It cuts out this window here and maybe even make it a bit smaller so that the rain can flow off this roof here. And then I would, turn off the diagnostic display and, for example, say I want to extrude these faces here and make a new window frame. So it's W-win. And I don't want to extrude them out. I just want to create a little window frame just so. Okay, so that we have a window. We don't need to see the face tags anymore. I just want to see what my building looks like. So here we go. This workflow here of selecting things and then using these nodes to produce something, that is exactly the workflow that you need here. I cannot pick something on the screen. I cannot, select components. I all have to describe everything without putting my hands on it. So you have to be careful with your whole face tag assignment, separating the pieces, keep the face tags as simple as possible, and then, work your way through. You see that the bevels, for example, don't have anything on them. I could now cut a window into this one here, and I can do that always everywhere in this construction history. Think of this whole row of nodes. That's your construction history. And it keeps working even if you plug in a different shape for this end object here. So let's go and pick the cube and use the controls for the polygon cube node to say, hey, I want a different height. And suddenly it subdivides itself into new floors and, even redistributes the whole instances with the random faces, etc., etc. And even when I change the depth here, it will re-subdivide itself. Here you see the windows on the roof and the windows on the side of the building. It re-subdivides everything to create new geometry to fit the size, right? So I hope this works for you. I hope this helps you get your first steps. In the package, there's the print pack that you need for the display of the face tags on the surfaces. And there are also some example files that you can load to have a look at this construction history. They are documented so you can see what each of these steps do. And for some of the buildings, it's important to turn off this construction history coming from the end. So you start at the end and turn all these faces, face operations off, and have a look at how it's subdivided in which order and what you need to do to be able to, create these floors here and rims around the building and extrudes and everything. Okay, I hope you like it.